Hi everyone, welcome to How to Electronics. Earlier, I explained about getting started with AWS IoT Core using ESP8266 Wi-Fi module. Now, this is the advanced version of the AWS IoT Core. In this project, we will build an industrial automation system using the ESP8266 Wi-Fi module and a custom-made industrial automation PCB. You can connect any AC appliances to relay and control whatever you like. In this demo, we will use AWS IoT MQTT protocol and subscribe to a topic to control the relays. This AWS IoT is an industrial-based service used by companies like Philips and Panasonic. Now, let's get started and see how we can build this system. Let us first build the hardware for this project. First, I draw the schematic using the Altium Designer software. My plan was to make a compact portable PCB for the project. So I chose assembly resistors, capacitors and LED. I chose 220 VAC to 5V DC converter from Highlink. For providing power to ESP8266 raw chip, I chose the ST7333 voltage regulator IC. The 4 channels relay is separated from the high power line using PC817 optocoupler IC. All the design requirements have been fulfilled in this design. I then designed the PCB using the same Altium Designer software. The PCB is compact and looks awesome. This is the 3D view of the PCB. This view basically tells how the PCB will look like. Then I generated curve file. It is time to order the PCB. So I visited ALLPCB, which is the official sponsor of this video as well. You can get your trial for PCB for only $1 here. It is very cheap compared to all other PCB manufacturers. I uploaded the curve file and filled in the details like material type, dimensions, quantities, thickness, solder mask color and other required parameters. Then I clicked on Export Now. Here you see the price is only $1. Now I selected my country of shipment and placed the order. Now after 5 days I received the PCB. Look at this PCB quality. It is very premium and has a perfect design for my project. If you want to order the PCB at $1, check the first link in the description. Now it is time to solder all the components on this PCB board. First, I collected all the components for this project. You can see this bill of materials that has the list of all the components for this project. I placed all the assembly components on this PCB first. Then, using the soldering hot air, I assembled all the components. Then I soldered all the through-hole components. Now you can see my PCB is ready. This is the ESP8266 chip. Power is supplied from here. The AC power is converted to 5V DC by this Highlink module. The voltage from Highlink is fed to this 3.3V regulator IC. This 3.3V IC supplied power to ESP chip and all other components. These are for optocoupler IC, which is separate from high voltage from the relay to the board. These 4 relays are used to control 4 industrial appliances. You can connect the AC appliances at the output terminal. These 4 push buttons are used for manual control. I haven't used this button for this project, but you can program it for manual feedback and controlling appliances manually. This 4 header can be used to solder 4 switches in place of 4 push buttons. At the back, you can see some diodes, transistors and resistors soldered. To program this ESP8266 chip, we can use this program pins. You can directly connect an FTDI module here and upload the code. Now it is time to set up the AWS IoT Core Dashboard. Visit Amazon AWS IoT Core Dashboard. Go to the Things option. Then create a thing here. Give the thing the name Home Automation. Click on Next. Select Auto Generate Certificate. Click on Next. We need to attach a policy here, but policy is not created. So first create a policy. Give policy any name like Home Policy. This is the most important section now. Here, you need to select IoT Connect. Under Policy Resource, write an asterisk sign. This will allow everything. Add a new statement now and do the same for IoT Publish. Do the same thing for IoT Receive and then IoT Subscribe. Finally, click on Create. Then policy will be created. Go back to the Things section now and select the policy here which we just created. From here, we need to download the certificates. First, download the device certificate and rename the file as device certificate for identification. Download the public key and rename it as well. Download the private key and rename it too. Finally, download the Amazon 𝗔𝗯cie𝘂𝘁 certificate. So we have 4 files. All these files are needed in the code part. Now click on Done. So the dashboard setup has been completed. Let's move to the coding part now. In the code part, we need a few ESP8266 libraries, PopShop client and Arduino JSON libraries. All the info is stored in secrets.h header file. We defined relay pins according to our PCB. In this line, we need to define a topic for a subscription. I used ESP8266/sub as a topic. These lines are for SSL connection with AWS Core. The NTP client function is used to retrieve time. Under the message receipt section, we are reading messages and decoding them. Based on the message, the relay is turned on/off. Under Void, connect AWS section. The ESP8266 is establishing a Wi-Fi connection and also a secure connection with AWS IoT Core. You can read the rest of the lines of the code and understand what's going on. In the secrets.h tab, we need multiple modifications. First, modify thing's name as Home Automation. From these lines, change the Wi-Fi SSID and password. We need to set up AWS IoT endpoint here. We will get this from the settings section of the AWS dashboard. Just copy it from here and paste it in the code. Here, we need to paste device certificate parameters. For this, open the device certificate using Notepad++ and paste the code here. Do the same for device private key. And finally modify the Amazon 𝗔𝗯cie𝘂𝘁 certificate here as well. Finally, code setup is done now. So it is time to upload the code. For that, first connect the ESP8266 with the FTDI module using the jumper wires. Then connect the FTDI module to the computer using the data cable. From the Tools menu, select generic ESP8266 port and then a COM port. Now you can upload the code. First, test the hardware. Open the serial monitor and wait for a few seconds to connect to Wi-Fi network and to the AWS IoT Core. On the AWS setup, go to MQTT test client section. From here, select Publish a topic. Give the topic name as ESP8266/sub. And under message payload, write on1 or on2 or on3 or on4 to turn on the respective relay. So send the message. Here you can see the message is received by serial monitor. This means the system is completely working. Let's see the hardware now. It has 4 LEDs for relays. I'm using a mobile dashboard to control the relay. After sending the on-off command, it works well. send commands from your AWS dashboard to control the relay. It works fine perfectly. You can retest again and again. I used these LEDs as a demo. You may connect your AC appliances to the relay for real-time results. The complete project details, including the bill of materials, schematic, PCB file, Gerber file, source code, and all other details have been uploaded on the How to Electronics website. You may read the AWS setup part as well. In case you have any doubt, comment down in the section below. Thank you for watching.